5-6, college algebra, pretty simple day. Using logs to help us solve problems about annuities and loan repayment, which is a big part of your life in the future, hopefully, that you borrow money so you can afford cool stuff. At the end of 2 years, the future value of an investment of $10,000. What is $10,000? Is it the principal or is it the amount that we've earned after the fact? That's the principal. That's the starting value. They invested money. It pays 8% compounded monthly. They've already given us the formula. Hopefully it makes sense. Here's your principal. Here's your monthly compounding. All right? Assuming no withdrawals or additional deposits, how long for the investment to reach $40,000? $40,000 is what we want the amount to be. So $40,000 goes in for S. And then before we get into solving this problem, I want to kind of explain to you how they'll ask you questions like on your final and on your test and all kinds of stuff like that. They might not say like, how long will it take for the amount to be $40,000? They might just say, how long would it take for the amount to quadruple? Or how much would it take for the amount to double? How much would it take for the amount to triple? Because a lot of times they might not even give you the starting value. People are like, well, wait a minute. How can I figure this out if they don't tell me how much we started with? We'll kind of get into that here in a second, but they won't tell you the starting amount and they won't tell you the final amount. They just say it had to double or it had to triple or it had to quadruple. So once we start solving this problem, it'll be pretty easy to understand how they'll do that. They want us to solve for t. Aren't they asking us how long it would take? T's in the exponent. All right? So first thing we got to do is realize who the base is. Isn't all of this bad boy the base of what's being raised to the exponent? We got to get him all by himself on one side of the equal sign. So we're going to get rid of times 10,000. Divide. What's 40,000 divided by 10,000? 4. And there it is, right there. There's your factor. What happened to the money? Did it double, quadruple, triple, or anything like that? It quadrupled. What number did we get in the final process once we've done all that? 4. Let's pretend, just for a little bit, that they gave us this instead. $80, and they wanted the money to quadruple. Wouldn't this have to be $320, right? 4 times as much. What would be your first move? Divide by 80. What would you get here? You would get a 4. Let's pretend that they said, hey man, what if we had $200 and you wanted your money to quadruple? Wouldn't there have to be an 800 right here? And then you divide, what would you end up getting right there? So when they don't tell you the principal, it's like you have a P right there. But you wanted the money to quadruple, so wouldn't you have a 4P right here instead? Then your first move is to divide both sides by P, and what's 4P divided by P turned out to be 4. If they want the money to quadruple, it doesn't matter how much you start with. This will always be 4 times as much. So when you do the division process, that will be a 4 every single time. Cool? Now, to solve this equation. It is not logarithmic. It is exponential. What I want to do is get him to come down. What do I need to do to solve this equation to get him to come down? Let's just say you had this. 4 equals, I don't know, just say 3 times to the x. What did you do on your homework to solve this, to get the x to come down? Can I square root both sides? Raise both sides to the reciprocal power, okay? So then you'd raise this to 1 over x and this to 1 over x, and then we're in trouble because we still have an x involved, right? You know, and it's not down low. Log both sides. If I did that, wouldn't this become log of 4 equals, the x comes in front then, log of 3, and now you're in good shape because doesn't the x come down in front? When you're trying to solve an exponential equation, to get the exponents to come down, you will log both sides. So let's do that to this guy. Let's log both sides. This would become the log of 4 equals, since we're logging this side, this entire exponent of 12t comes in front, and I'd get the log of that whole messy thing right there. I'm just going to leave him like that. I'm not going to try to type him in. Sometimes that number in the parentheses is okay to deal with. Sometimes it's repeating. It's like, it's nasty. I'm just going to leave him like that. But the cool thing that we just did is we got t to come down from the exponent land into the normal height land of where the bases are. What would I do to get t all by itself? Well, check it out. All this stuff is being multiplied. That's just one giant term. Because remember, when stuff's in the grouping symbol, you don't really get to see what's in there. There's no adding between these terms. There's no subtracting between these things. That's just one fatty boom batty term. What would you do to get t all by itself? Divide by all the stuff that we are getting multiplied by to both sides. All I did was divide both sides by stuff that's going to cross out. 12 over 12 cancels. The log of this over the log of that cancels out. And the only thing left there is that t. So t equals, and now it's time to punch this into the calculator. Takes a little bit of process, so let me move my calculator into the right position. What I'm going to do is punch this stuff in first. Give me a second. So I'll type in 0.08 divided by 12, hit equals, that's this part, add 1 to it, hit equals. Cool? So far, all I figured out was what this number was. You with me? What do I need to do that guy? I got to log him. So log of my answer is that. Cool? Now I got to take him times 12. Right? So that's my entire denominator. You with me on that? What I need to do now is take log of 4, make sure you close that parenthesis, and divide it by that answer. And it should make some sort of reasonable sense. This is time in years. It probably won't come out to be nice, you know. So it says round. Does it tell you how to round? If not, we'll round to the nearest tenth. About 17.4 years. About 17.4 years. Cool with that? Let's try another one. Read it. So they want the amount to be 60,000. That goes in for S. We started with 25,000. And that's what we got. Right? They want us to figure out how long it will take for this to reach 60,000. So again, the first move is to get this whole mamma jamma by himself. We would divide by 25,000. So 60,000 divided by 25,000. 2.4. I'll just leave him a cool decimal. Came out nice and clean. Everyone down with that move so far? Now I got to get the t to come down in front. How do you get that to happen since he's in an exponent? Log both sides. Log of 2.4 equals 4t, which came in front, times the log of that whole quantity. Awesome. Then you divide both sides by all that other stuff. So it's a log of 2.4 over 4 log of 1 point plus 0.12 over 4. And now we punch that stuff in. 0.12 divided by 4. Nice. Plus 1. Nice. 1.03. Nice and clean. What do you got to do to 1.03 first, though? Log that answer. Then take him times 4. And then take the log of 2.4. Close the parentheses. And divide it by that answer. See if you get the same thing I got. Did we get that or not get that? Typos is the hardest part about all this stuff. Algebra's there. It's a real simple process. It's ugly looking, but punching it in your calculator is the hard part. Sweet. About 7.4 years. Nice. See what you can do on this one. I'll let you read it and set up an equation for me. This guy goes in for P since he is the price, right? And P stands for price, so 10,880 equals 340 times 2 to the Q. That's awesome. It's like you're going for cheeseburgers with your friend. 2 to the Q. What's your first move, though, before you can log both sides? You don't want to log both sides first. You got to get 2 to the Q all by themselves. So divide by 340. 10,880 divided by 340. Oh, nice. 32 equals 2 to the Q. You could log both sides, but there's an easier way. Because this guy over here is base 2, if it's possible to write 32 as a power of 2, then we could be swift and easy done with this. You definitely know 2 to the third is 8. So what's 2 to the fourth then? 16. That means 2 to the fifth is how much? So that's 32. Right? This is the same thing. And now that they both have the same base, those exponents should be equal, and Q equals a 5. 5 what, though? 5 boats. This was like 2012. You could be on a boat. Nice. Next, half-life problems. The amount of radioactive isotope thorium-234 present in a certain sample of time t is given by that cool formula right there, where t is the time since the initial amount was measured. Find the initial amount of the isotope. Two ways to think of it. The initial amount is when time is 0, right? Like according to your experiment, time hasn't passed yet. You have time 0. If you put 0 in right here, which is t, what would this nasty decimal times 0 turn out to be? 0. Then you'd have e to the 0th, which is how much? 1 times 500, which is 500. It's very much like your principal situation right here. That's your starting value because the exponent would turn out to be 0 when you're in an initial problem. It says find the half-life of this isotope. That is the number of years until half the original amount of the isotope remains. So let me put this in a full window real quick. There's two ways you could think of it. Do you know how much you started with? We started with 500. What's half of that? So you'd need to know when you have 250 equals your formula that they provided. 250 goes in for the amount you wanted, negative 0.02828t. That's really what's supposed to happen first. But then, since this is exponential, you try to get the base all by himself. E is the base. Wouldn't you divide both sides by 500? And what would 250 divided by 500 be? 1/2. Wow. We tried to find the half-life, and what did that number turn out to equal over here? It equals 1/2. Just like if you wanted to double your money, that number would turn out to be a 2. If you wanted to triple your money, that number would turn out to be a 3. You wanted half the amount, that number turned out to be 1/2. You could log both sides if you want to bring that exponent down. That would be a silly thing to do when the base is e. You would much rather do what instead of log both sides? Natural log both sides. The reason why you want to do that is right here is something very special for you. That natural log of e is really how much? It's 1. So it's like that doesn't even happen, right? You can just kind of erase it because it's times 1 right there. But to solve for t, we must now divide both sides by the negative nasty. So I go to Mr. Calculator, natural log of 1/2, which you can type in as 0.5. Just make sure you close that parenthesis, divided by Mr. Nasty. Oops, that's not the calculator. About 25.5 years. 24.5, thank you. 24.5 years. Cool. What that means is, dude, they had 500 grams or whatever that element was laying there. 24.5 years later, it would deteriorate, and there's only half as much left. Now there's 250 grams. Then another 25 years later, if this pattern holds true, then there'd only be 125 grams left later. And then after that, another half. So whatever half of 125 is. Cool. Read. Just read. They want us to read that and double our investment. They didn't tell us our principal. We could care less about the principal, because if you started with 100, wouldn't it turn out to be 200? If you started with 1,000,000, it would turn out to be 2 million. What's the relationship between them every time? Double. So what number really goes right here? 2. And then you just let your principal be 1. You know, it's like you don't know how much you start with. So in general terms, why don't you just say you started with $1, and then it turns into $2, right? It's double. But they didn't really ask us to solve for t, per se. They wanted us to find a formula. Well, it's the basic idea, solve for t. And that would tell you the time. So what would I do to solve for t? Since he's an exponent. Log both sides. Log of 2 equals t log of 1.07. And this is simple, since it's annual deal, log of 2 over log of 1.07. And that's it. They don't want you to get a decimal because they want a formula for this. So t equals the log of 2 over the log of 1.07. Now let's see if you can really think about stuff. What if they wanted it to triple? What's the only thing that would change in this formula? The 2 is a 3. If they wanted it to quadruple, it would be a 4 there. But this is a simple one due to the fact that it was annual interest. You didn't have that nasty fraction stuff inside of there. So it's the general idea. It's the log of whatever you want to have happen divided by, you know, when that exponent is a times 12t and stuff like that, etc. It becomes a little nastier. But that's the formula.
All right, now on to some annuities. An annuity is a financial plan characterized by regular payments. Now, there's lots of types of annuities out there. If you want to know more, you can go to YouTube and kind of see what kind of what kind of annuities are out there. But now it's like, instead of just putting one lump sum away, you know, it's like we're going to do regular payments, so like maybe $50 a month or $1,000 a year or something like that, you know. So regular payments. So the formula for the future value of an ordinary annuity, so like I said, there's a lot of types of annuities, so this is for a future value of an ordinary annuity, is this, where R stands for the amount invested. That's just like your principal right there. I is the interest rate per period, and that's going to get a little tricky here. And N is the number of periods. So like if it was like how many times a month, and well, the periods we'll kind of talk about here shortly. So suppose $1,000 is invested at the end of each year, right? So every year they're going to put $1,000 away for 5 years in an account that pays 10% interest compounded annually. So let's kind of figure some of this stuff out right here. We know R. R is the initial amount invested. R is $1,000. And it's going to happen every year, right? But that's what they meant. You know, it's like how many times are you doing, or what are you investing every time? So you're going to make continuous payments of the same amount, $1,000. I is our interest per period, right? So we're getting 10% interest, right? So that's 0.1. But then you got to divide it by like how many times it's happening per year. And since it's happening annually, it's happening once. So it's still going to give you 10%, right? But when we do it twice a year or quarterly or something like that, that's going to change. And the number of periods, well, we're going to go for 5 years times the number of times per year, right, which is 1, so that's going to give us 5 in that situation. So there's 5 periods. So pretty simple. They just want us to substitute in. So S will equal 1,000 times 1 plus 0.1, because that's our interest rate, to the nth power, and n is 5, minus 1 over the interest rate again, which is 0.1. So we just need to punch this in. And what we'll do is we'll kind of work from the inside out here. I want to do 1.1. I already did that. 1 plus 0.1 to the fifth. And hit equals. So I've done that. Now I'm going to take away 1 and hit equals. Divided by 0.1. And then take it times 1,000. 1, 2, 3 zeros. And that's $6,105.10. So let's figure out how much of that was actually our money, you know? It's like, really, we put $1,000 away for 5 years, so isn't 5,000 of that our money? So we made $1,105 in interest in that situation. That's not bad for a 5-year span, you know? So $1,000 a year for 5 years, and we just kept earning the interest, so this annuity was pretty cool. All right, so now let's check this out. It says find the 5-year future option of an ordinary annuity with a contribution of $500 per quarter in an account that pays 8% per year compounded quarterly. So quarterly. All right. Let's figure some stuff out again. Here I brought that formula in. We know R is $500. We're doing that every quarter. Right? So that interest rate is per period, right? So it's 8%, which is 0.08. But since we're going quarterly, right, we've got to divide it by 4, because quarterly means 4, and that'll give us 0.02, like 2%. So like every quarter, you're basically making 2% in that situation. And the number of periods, well, we're doing 5 years, right? So years times how many times per year? 4 times, so it'd be 20 different periods to where we'd earn interest, because you get it 4 times a year for 5 years. So it's years times like how many times it's getting compounded, basically, in that situation. So once you get these ingredients, then it's just money going into the formula, right? So S will equal 500, 1 plus 0.02, right, because that's what I is, to the nth, which is 20, minus 1 over 0.02, and then we punch that in. So 1.02 to the 20th equals minus 1 equals divided by 0.02 equals, and then times 500. So $12,148.69 basically. So how much money of that was actually ours? So we did $500 20 times, you know, because you're doing it for 20 periods. So 500 times 20. We actually put in $10,000, and we got 2,000, etc., in interest in that situation. So it's just a kind of a cool deal. Like, you're putting your money away, and you're doing so much per quarter or per whatever period in that situation. So let's check this guy out. Let's say you did something like this. On the day you got your first paycheck, your parents make you put $50 a month away for savings in an annuity that pays you 6% interest compounded monthly. You promised yourself you would keep this up until you retired. So assuming you were 15 years old when you started, how much is in the account when you retire? So again, I just went and grabbed that formula real quick, but we know R is we're doing $50 a month, right? So R is 50. I is the interest per period, so it's definitely that 6%, whatever they tell you, and then you got to divide it by the number of periods, which is monthly, so that's 12, if my pen would work, and you divide that out, and that is 0.005. Let's double check that real quick before we go too far, Mr. P. And yes, that is right. And then I need to know the number of periods. The number of periods, we're going 12 times a year, right, for 50 years. So 50 years times 12. We've got 600. That's a big fat winner. So 600 different times we're going to like put 50 bucks a month away and we're going to earn interest on that. So let's see how much we get when we retire. So S equals 50 times 1 plus I is 0.005 to the 600th, big boy, minus 1 all over 0.005. This pen. So 1.005 to the 600th. That should be big. Minus 1 divided by 0.005. It's going to get big. Times 50. Yeah. So that is $189,359.55. Let's see how much of that was our money. Remember, we put 50 bucks a month away for basically 600 months, right? So 50 times 600, 30,000 in that situation. So for $30,000, over a span of 50 years is all that cost you, which is chump change, 600 bucks a year. You could then draw out that you have basically about $190,000. So that's not too shabby right there. Free money. One more problem. It's not even on the worksheet, right? So, but it is on my math lab, so there's a problem like it. Another type of annuity you could do is like when you want to retire and you want to receive payments per month, so like you quit working and it's like, hey, I'd still like to get some income, so you could invest stuff into an annuity to pay you after you retire. Or like this guy here, he got into an accident. Like a man got disabled and is in an accident and wants to receive an insurance payment that's going to provide him with this much money at the end of each month for 5 years. The payment is going to go into an account that pays 6% compounded monthly. What size payment should he seek? So the dude got in a wreck, right? And he's looking for the insurance company to get some money, right? How much money should he seek, right? It's like, how much should the insurance money give him? Well, he wants enough to do $2,800 a month. But he knows he's smart, and he's going to put it into this annuity to where he's going to get some money from the insurance, and that's going to make interest, and that will allow him to pay him this much money. So, all right, now the R's and the I's and the N's might not be the same thing because we have a new formula here, right? So a payment of R dollars is to be made at the end of each period. So R is like the amount that this guy wants per month, and that's the $2,800. Right? So R equals $2,800. That's how much the insurance company, or the annuity, I should say. It's not the insurance company, it's the annuity that's going to pay this guy $2,800 a month. I is still the same thing. I is the interest per period, so it's the 6% divided by 12 because we're doing monthly, which is the same number we just had, 0.005. And the number of periods is still the same. You're doing 5 years. That's all this guy wants money for. It's just 5 years, and he's getting it 12 times a period, right? So that'll give you 60 in that situation. And this will tell us how much this guy should ask for from the insurance company. So the amount he wants will be the 2,800 times all this stuff, 1 minus 1 plus 0.005 to the negative 60th, right? That's different, over 0.005. So, given the formula and figuring all this out, we can punch this stuff in now. That would be, I'm going to work from inside out, 1.005 to the negative 60th. Now, and then 1 minus that, so 1 minus the previous answer equals, then divided by 0.005, and then times 2,800. Yeah, come on, zeros. Thank you. And this guy, according to this, says it should seek a payment of $144,000 $831.57. So this is what he should ask from the insurance company, right? It's like, yo, man, I need this. Obviously, you can get more, take more. If the insurance company is saying, dude, your wreck was bad, here's 200 grand. I mean, obviously you're gonna take it, but this is what he needs to seek to be able to pay the bills that he wants because he, for some reason, knows that he needs about 2,800 bucks a month to survive, right? Now, just for fun, let's realize how much money he actually gets back from this annuity. He's doing 2,800 bucks a month, right? And then that was for 60 months because we figured that out. He's actually getting $168,000 from the money that he seeks because he put a big old fat $145,000 in an account and it's earning interest over that 5-year period per month and all that stuff. So that's the whole idea of retirement annuities and stuff like that. So, all right, that should be enough to get you going on my math lab. Let me know if you have any questions and have a good